represent a combination of different technologies. For example, SObjs, ROA and ScriptMIB, SOA and OSGI, and etc. So this we could achieve that OSG and ROA behaved stable, was the most stable result and with good results. And this is the traffic related to the different technologies to implement our solution. So also the ROA and SGI behave very well, and this was a set of technologies that we deploy our solution. Define the technologies, then we deployed our experiment inside the second scenario, where we did the last two research questions. That is, how does MbDSAS behave within a dynamic IoT scenario where smart objects join and leave very frequently? MbDSAS in the first result here presents a 60-second of management delay, more than the traditional management system, because it has a startup time where it has to detect the smart object, the TLM will collect the MDL, and then will delegate the scripts to manage them. So it may be take as a cost to add this dynamic reconfiguration features and smart object our system, our mechanisms to engage. And in the final question, how many computational resources of a gateway are needed to execute MbDSAS in terms of memory and CPU utilization? As you can see here, MbDSAS and the traditional management system behave almost the same, using almost the same CPU resources, and this is good because, as I said, MbDSAS presents two new features, and almost the same resources were spent to execute it. But when we come to the memory was a little different. First, both systems starts to allocate memory, and then at the middle of our experiment, when the smart object starts to leave the network, MbDSAS starts to deallocate memory and greening the memory resource. And this is pretty interesting because you can now deallocate more memory and use this memory to other processes. So finally, MbDSAS is a solution to the management of smart objects of the IoT. And through the MbDSAS, gateways offer dynamic configuration features combined to smart object awareness mechanism to manage the IoT. Our results confirm the efficiency of MbDSAS as a solution to manage dynamic IoT scenarios, using less computational resources, however, presenting a managed delay to reconfigure a gate on the fly. But as I said, it's a little unfair to compare with this traditional solution, because it's like to think that there is a solution that is enabled to manage every different kind of smart object in the world. I think this is a little impossible. So our future work, we believe that in the near future, MbDSAS may be used in combined with mashup systems to allow managers not very without very skilled, not very skilled, to build their own systems based on MBD, and also to create new and complex systems based on the composition of web services with our solution. For example, using MBD to reconfigure a grid of smart objects where it was influenced by the weather, for example, and then combine the web service of weather.com, for example, with our solution to make a very, very singular solution. So thank you. Any questions?
Thank you. I have two questions. Currently you have the experience with maximally 200 people, right?
Yes.
So I think it's a little bit small amount of the people. So I think you should have the
more
yes.
tools. Yes, it was a hard experiment because actually we had to take the cluster of our university, and these 200 smart objects are very different from each one. So it's very number and type, and at that point we thought that 200 smart objects scenario. I believe that 200 smart objects passing nearby a single switch. I think it's enough, but it's my opinion. There is not related to anything. So because I think there in a real scenario will not be just a switch. Will be a lot of different switches in an airport station. So I believe that this small number, I believe that's more related to the real one. But it's my opinion.
Okay. So I have another question. Who defines script?
Yes, script.
Who defines?
Who?
I mean, who?
Who defines script?
Yes.
Who defines?
Who? Quem?
Who defines script?
Yes.
As I said, there are two ways for define the scripts. First, the manager of the network may create their own scripts to manage their own domains. And the second one is based on recommender systems, where the community can share their scripts on the internet, and by recommendation, they will be defined on the fly. Like, this script was good to this kind of device because it matched very well when do like a polling system or I don't know, and this is good. And then all the other users that use the system may contribute with their opinion and reach the better script. So it's or community based or made by managers itself. It will depend on the domain needs, because the IoT itself it will be composed by a lot of different network domains. So I believe that both of them may be used, because for very small network domains, like I said, a manager to delegate their own scripts, like in a hospital network, it would be more suitable. But for the whole network, like a federative network, or I don't know, some part or the entire network of the Internet of Things, community-based solution is more suitable. Sorry.
Okay, so how do you evaluate the script? So in your system, long script, if you put the long script in your system, system go to bad behavior, I think.
I don't get it.
Okay, I would like to talk after that session.
Oh, okay, it will be nice.
Okay, thanks. Thanks,
Thank you very much.
Any other questions?
Probably a quick question. I'm sorry if I've just missed it, but could you give me some examples of smart objects in your scenario?
Oh, okay. Our objects were based on hospital-based ones, because Remoa is a project to telemonitoring. So we were basing like very specific device, like for example Code Blue One and other smartphones and other things like that. And the script were yes.
Okay, so we'd like to the next paper.
Yes.
Thank you.
Thank you.